21 medical facts about the brain. The human brain is the most complex organ in the body. Scientists are still discovering how powerful and mysterious it truly is, a biological supercomputer that never truly rests. 1. The neural universe, 86 billion neurons. The scale of the brain's hardware is staggering. It contains approximately 86 billion neurons, which are the fundamental units of the nervous system. To put that in perspective, if every neuron were a second, it would take over 2,700 years to count them all. But the true complexity lies in their connectivity. Each neuron can form thousands of synapses, creating a web of over 100 trillion connections. This massive parallel processing network allows you to recognize a face, solve a math problem, and maintain your balance simultaneously. It is the most dense and sophisticated communication network in the known universe, far surpassing any man-made computer in efficiency and adaptability. 2. The master controller, oversight of every organ. The brain is the CEO of your biological corporation. Through the autonomic nervous system, it maintains an invisible 24/7 surveillance over every organ in your body. It regulates your heart rate, coordinates the rhythmic contraction of your intestines for digestion, and monitors the chemical composition of your blood to adjust your breathing. Even organs that seem automatic are under the brain's thumb. For instance, the brain can signal the kidneys to conserve water, or tell the adrenal glands to flood the body with energy during a crisis. Without this centralized processing unit, the various systems of your body would fail to synchronize, leading to immediate physiological chaos. 3. The oxygen glutton, high metabolic demand. Despite making up only about 2% of your body weight, the brain is an energy-hungry organ that consumes roughly 20% of your body's total oxygen and glucose supply. It cannot store energy, meaning it requires a constant, uninterrupted flow of oxygenated blood. This high demand is due to the sodium-potassium pump in neurons, which requires massive amounts of ATP, cellular fuel, to maintain the electrical charge necessary for neural firing. If blood flow to the brain is cut off for even a few minutes, neurons begin to die from oxygen starvation. This is why the brain has a dedicated circle of Willis, a redundant vascular loop at the base of the brain designed to ensure blood reaches all areas, even if one artery is blocked. 4. The architecture of mind, forming memories. Memories are not stored in a single file, like on a hard drive. They are living architectural changes in the brain. When you learn something new or experience an event, your neurons fire in a specific pattern, strengthening the synapses between them, a process called long-term potentiation. This effectively creates a physical pathway of least resistance. Over time, these connections are reinforced by a protein called myelin, which acts like insulation on a wire, making the signal travel faster and more efficiently. Your memory is literally a map of how your brain has been physically rewired by your experiences, turning abstract thoughts into permanent biological structures. 5. The grand interpreter, processing pain signals. One of the most paradoxical facts in medicine is that the brain itself has no pain receptors, nociceptors, yet it is the only place where pain actually exists. When you stub your toe, danger signals travel up your nerves to the brain. It is the brain that interprets these electrical pulses as pain, deciding how intense it should feel based on your environment, emotions, and past experiences. This is why phantom limb pain exists. The brain continues to simulate the sensation of pain in a limb that is no longer there. Pain is not a direct feeling from the body, but an executive opinion rendered by the brain to protect you from perceived damage. 6. The night shift, neural activity during sleep. The idea that the brain turns off during sleep is one of the most persistent myths in biology. In reality, the brain is often more metabolically active during sleep than it is during the day. While you are unconscious, the brain performs a high-speed system backup. In the REM, rapid eye movement stage, your brain activity mimics that of a person who is wide awake, as it processes emotions and simulates scenarios through dreams. Simultaneously, the brain's glymphatic system kicks into high gear, essentially acting as a biological dishwasher that flushes out metabolic waste and toxic proteins like beta-amyloid, which are linked to neurodegeneration. Sleep is not a passive state, but a period of intense maintenance, during which the brain prioritizes its internal health over external sensory processing. Without this nightly cleanup and reorganization, cognitive function would rapidly deteriorate under the weight of accumulated neural debris and unorganized data. 7. The infinite path, learning and neuroplasticity. Every time you learn a new skill, whether it is a foreign language or a complex physical movement, your brain undergoes a physical transformation known as neuroplasticity. This isn't just a metaphor. It involves the creation of new synapses and the strengthening of existing ones through a process called synaptic pruning and long-term potentiation. When a neural circuit is fired repeatedly, the brain wraps the connecting axons in a fatty substance called myelin. Myelin acts as high-speed insulation, allowing electrical impulses to travel up to 100 times faster. This structural change explains why a task that feels impossible at first eventually becomes second nature. The brain is essentially a living muscle of information. It can grow, shrink, and reorganize its entire functional map based on the demands you place upon it. This adaptability is the foundation of human resilience, allowing the brain to forge new pathways even after significant trauma or changes in environment. 8. The chemical storm. How stress alters brain circuitry. Stress is not just a feeling. It is a powerful chemical state that can physically reshape the brain's architecture. When the brain perceives a threat, the hypothalamus triggers the release of cortisol, the primary stress hormone. While a brief burst of cortisol is life-saving, chronic exposure is neurotoxic. High levels of cortisol can actually cause the amygdala, the brain's fear center, to grow and become hyperreactive, while simultaneously shrinking the hippocampus, the center for memory and learning. This chemical storm weakens the prefrontal cortex, the area responsible for logical decision-making and impulse control. Essentially, chronic stress forces the brain to stay in a survival mode, making it harder to think creatively or remember information. Over time, this can lead to a permanent shift in brain chemistry, making an individual more susceptible to anxiety and depression, as the brain becomes wired to prioritize fear over rational thought and emotional regulation. 9. The neurogenic spark. How exercise rebuilds the brain. Physical exercise is perhaps the most powerful, smart drug known to science. When you engage in aerobic activity, your brain increases the production of a protein called brain-derived neurotrophic factor, BDNF. Scientists refer to BDNF as miracle grow for the brain because it stimulates the growth of new neurons in the hippocampus, the region most associated with memory and cognitive function, a process called neurogenesis. Exercise also increases blood flow and the density of capillaries in the brain, ensuring that neurons receive a more efficient supply of oxygen and glucose. Furthermore, physical movement helps regulate neurotransmitters like dopamine and serotonin, which are essential for focus and mood. By staying active, you aren't just training your muscles, you are literally forcing your brain to produce the chemical signals required for cellular repair and neural growth, which acts as a powerful defense against age-related cognitive decline and the onset of dementia. 10. The adaptive survivor, recovery after brain injury. The brain's ability to recover from injury is one of the most inspiring examples of biological redundancy. Through a mechanism called functional compensation, the brain can often bypass damaged areas by rerouting signals to healthy tissues. If the area responsible for speech in the left hemisphere is injured, the right hemisphere can sometimes adapt to take over those linguistic functions. This is achieved through the sprouting of new dendrites and the recruitment of silent synapses that were previously inactive. While neurons themselves do not regenerate as easily as skin cells, the brain's massive network is designed to find workarounds. This explains how stroke victims can relearn to walk or talk through intense rehabilitation. The brain doesn't just fix a broken part, it re-engineers its entire internal network to ensure that vital functions continue. It is a testament to the brain's plastic nature. It is a system designed to survive and maintain consciousness at almost any cost. 11. The emotional engine, the role of the limbic system. Everything you feel, from the heights of joy to the depths of sorrow, is a result of the limbic system, a collection of structures located deep within the brain. The center of this system is the hypothalamus, which translates emotions into physical responses, such as a racing heart or a gut feeling. The amygdala acts as an emotional radar, constantly scanning the environment for threats and tagging memories with emotional importance. Without the limbic system, life would be a series of cold, logical observations, without any subjective meaning. Interestingly, the limbic system often processes information faster than the logical prefrontal cortex, which is why we often have an emotional reaction before we have even fully understood what is happening. This emotional engine is essential for decision-making. Without the ability to assign an emotional value to different outcomes, the human brain finds it almost impossible to make even the simplest choices, proving that logic and emotion are biologically inseparable. 12. The universal language, music and global brain activation. Music is one of the few activities that activates almost every known part of the brain simultaneously. When you listen to a melody, the auditory cortex processes the sound, while the frontal lobe analyzes the structure and rhythm. If the music has an emotional impact, the limbic system lights up, and if you tap your foot, the motor cortex and cerebellum become engaged. This global activation makes music a powerful tool for neurorehabilitation. For instance, patients who have lost the ability to speak due to a stroke, aphasia, can often still sing their words because singing uses different neural pathways than speaking. Music also triggers the release of dopamine, the brain's reward chemical, which is why it can be as addictive and emotionally powerful as food or social interaction. This profound connection between music and the brain suggests that rhythm and melody are not just cultural inventions, but are deeply rooted in our evolutionary neurobiology as a primary form of human communication and social bonding. 13. The bioelectric storm, neural signaling and electricity. At its core, your brain is a biological power plant. Every thought, sensation, and movement is powered by tiny electrical signals called action potentials. These signals are generated by the movement of charged ions, sodium, potassium, and calcium, across the membranes of your neuron. While the amount of electricity generated by a single neuron is minuscule, the collective activity of 86 billion neurons can generate enough power to light a low-wattage LED bulb, about 20 watts. This bioelectricity is what allows the brain to process information at incredible speeds, with signals traveling at up to 270 miles per hour. This electrical nature is why the brain is so sensitive to electromagnetic fields, and why doctors can use tools like EEG, electroencephalography, to read your brain activity, or ECT, electroconvulsive therapy, to reset it. You are, quite literally, an ongoing electrical storm, and your consciousness is the result of the complex, rhythmic patterns of this internal lightning. 14. The restorative silence, sleep, and neural maintenance. Sleep is the only time the brain can perform its most critical housekeeping tasks. During deep NREM, non-rapid eye movement, sleep, the brain enters a state of slow-wave activity that allows it to consolidate memories and clear the cache of the previous day's information. This is also when the glymphatic system, the brain's waste clearance system, is most active, flushing out toxins that accumulate during waking hours. Without enough sleep, these toxins, such as beta amyloid, build up and begin to interfere with neural communication, leading to brain fog and impaired judgment. Chronic sleep deprivation is not just a lifestyle issue. It is a biological crisis that forces the brain to eat its own synapses to maintain basic function. Sleep is the restorative silence required for the brain's electrical and chemical systems to recalibrate, ensuring that the organic computer doesn't overheat or crash under the weight of its own data. 15. The memory vault, the hippocampus and navigation. Located deep within the temporal lobe, the hippocampus is the brain's primary gateway for memory and spatial navigation. It acts like a sorting station, taking in raw sensory data and deciding what should be converted into long-term memories. Interestingly, the hippocampus is also responsible for our mental map of the world. Research on London taxi drivers revealed that their hippocampi actually grew in size as they memorized the complex knowledge of the city's streets. The hippocampus is one of the few areas of the adult brain capable of neurogenesis, growing new neurons, making it the center of cognitive growth. However, it is also one of the first areas to be affected by Alzheimer's disease and chronic stress, leading to the disorientation and memory loss associated with those conditions. It is the vital vault of your personal identity. Without it, you would live in a permanent now, unable to form a connection between your past experiences and your future goals. 16. The speed of sight, rapid visual processing. The brain is a visual powerhouse, with nearly 30% of the cortex dedicated to processing sight. While a high-speed computer takes time to analyze pixels, the human brain can identify an image in as little as 13 milliseconds. This incredible speed is due to parallel processing, where the brain simultaneously analyzes color, motion, shape, and depth through different neural streams. The visual cortex doesn't just see what is there, it actively predicts what should be there based on past patterns. This is why optical illusions work. Your brain is filling in the blanks faster than your eyes can actually record the data. This rapid processing was an evolutionary necessity, allowing our ancestors to detect a predator in the shadows long before the conscious mind had even registered the threat. Your vision is not a passive video feed. It is a high-speed construction project where the brain interprets light into a meaningful reality at a pace that remains unmatched by any artificial intelligence. 17. The biological clock, hypothalamic hormone control. The hypothalamus is a tiny region, roughly the size of an almond, but it functions as the brain's command and control center for your entire endocrine system. It acts as a bridge between the nervous system and the hormonal system, regulating everything from body temperature and hunger to your circadian rhythm. By controlling the pituitary gland, the master gland, the hypothalamus coordinates the release of hormones that govern growth, metabolism, and reproductive health. It is constantly monitoring the chemical composition of your blood and adjusting your internal state to maintain homeostasis, the perfect biological balance. If you feel thirsty, sleepy, or stressed, it is the hypothalamus that has detected a deficit and is firing the chemical signals to force you to react. It is the silent regulator of your life, ensuring that your body's internal environment remains stable and survivable regardless of the chaotic changes happening in the world outside. 18. The sculpted mind, meditation and brain plasticity. Meditation was once considered a purely spiritual practice, but modern neuroimaging has proven that it causes physical changes in the brain's structure. Regular meditation increases the density of gray matter in the prefrontal cortex, the area for focus and decision-making, and the insula, the area for self-awareness. Simultaneously, it has been shown to shrink the amygdala, the brain's fear center, making it less reactive to stress. This process, known as activity-dependent plasticity, means that by simply changing your thought patterns, you are physically rewiring your brain to be calmer and more focused. This is not just a temporary state of relaxation, it is a permanent architectural shift. Long-term practitioners of meditation show a younger brain age compared to their peers, as the practice strengthens the connections between different brain regions and prevents the age-related thinning of the cortex. It is the ultimate proof that the mind has the power to intentionally shape the physical organ that houses it. 19. The processing gap, aging and cognitive speed. As we age, the brain undergoes a process of neural slowing, but this is not necessarily a sign of decline. While it is true that processing speed and working memory peak in the early 20s, the white matter, the fatty insulation on neurons, continues to develop and improve well into middle age. Aging brains often compensate for slower individual connections by using bilateralization, using both sides of the brain to solve a problem that a younger person would only use one side for. This is the biological basis for wisdom. The aging brain has a larger library of patterns and experiences to draw from, allowing it to see the big picture, even if it takes slightly longer to recall a specific name. While the raw speed of the processor may decrease over time, the software and the complexity of the internal network continue to grow, proving that a mature brain is optimized for complex judgment and emotional stability, rather than just the rapid-fire reaction of youth. 20. The synaptic bridge, chemical communication. The 86 billion neurons in your brain never actually touch. Instead, they communicate across a microscopic gap called a synapse. When an electrical signal reaches the end of a neuron, it triggers the release of neurotransmitters, chemical messengers like dopamine, serotonin, and glutamate. These chemicals float across the gap and lock into receptors on the next neuron, like a key into a lock, passing the message along. This chemical nature of the brain is what allows it to be so flexible and complex. It also explains why medicines, caffeine, and even the food we eat can so profoundly change our thoughts and feelings. They are essentially interfering with the chemical traffic at the synapse. There are over 100 trillion of these bridges in your brain, and every thought you have is a result of a specific chemical handshake across these gaps, making the synapse the most important site of human consciousness and medical intervention. 21. The living engine, mental stimulation and health. The brain operates on a strict use it or lose it principle. Just as muscles atrophy without exercise, neural pathways that are not used begin to wither and be pruned away. Mental stimulation, whether through reading, learning a new language, or engaging in complex social interaction, forces the brain to maintain its synaptic density. This creates what neurologists call cognitive reserve. People with high cognitive reserve can actually have the physical markers of Alzheimer's disease in their brains, but show no symptoms of dementia because their internal network is so robust and redundant that the brain simply finds another way around the damage. Challenging your brain with new and difficult tasks is the single most effective way to maintain its structural integrity. Every time you push yourself to understand something complex, you are essentially armoring your brain against the future, ensuring that your neural command center remains sharp, resilient, and functional well into your final years.